Hey friends, as we discussed the brute force approach yesterday, uh, where we had tried to find the LCA using two arrays or simply using extra space. Now let's understand how we can achieve the same by not using an extra space. See, I'm not talking about the recursive stack that it builds internally. I'm talking about the extra containers. Okay, like previously we had used two vectors, yeah, and we just traverse two times, something like that. So I hope you get the solution or get a clear understanding of this problem, and I expect that I'm expecting that you had already gone through the last video, and if you did not watch it, then please go back to that particular video, and I will just that particular link will just appear the last of this video, and please come back to here to understand this particular approach. Okay, so here I have prepared one example. Okay, binary tree where we will try to understand the things. So here let's take two example. Let's take an example, let's say 7 and 4. Okay, cool. So here the point of diversion is 2. If we just if we just draw the path from route to each of the destinations, then we see that from 2 the path is diverted, isn't it? So to do this, we had used two arrays to store the path and found the previous node of that particular point where the mismatch happened, isn't it? But the problem with that was we traversed two times in the binary tree to find out the path of each given node. And also we were storing them in two arrays. So those are some complexity measures, and we need to optimize it in terms of both time and space complexity as well. Okay. So look at the example. Here 2 is the LCA. If somehow I find a flag from its left subtree, which is saying that one of the two nodes is present in the left subtree, and same case is for right. Okay. If I found a flag from right subtree, which is saying that one of these two nodes present a right subtree, then can I say that this particular, this particular node is the least common ancestor? Yes, I can say. If 7 returns to a flag variable saying that yeah, I am one of these two nodes and I am present in the left subtree. Similar case for 4. Okay, then 2 is the least common ancestor. Okay, because both of the nodes present in both of the direction of this particular root node. I mean for this particular state. If we would just assume this particular tree. Cool. So there are few cases that need to be understood, from beginning. So see, there can be case like if this particular node, received one not null, variable or flag, and one null variable from this flag. Okay, let's say this is not 4, this is something else. Let's say 5. Okay, and we were finding let's say this is 4. Okay, and we were finding 7 and 4. Cool. Okay, one sec, let me pick the pen. Yeah, and let's say we were finding 7 and 4. Then one of these two nodes, you know uh, just returning a not null flag, and one of the node is returning a null flag here in this particular example. So what will happen in this particular example? See, here we cannot say that 2 is the LCA. Why? Because 2 is not, no more the diversion point, isn't it? Because here we are just going to the 7, but we are not, we did not find any 4 right here in the right subtract. That is why we cannot say that 2 is the LCA. But what this particular 2 will return to its parent. See, whatever is the not null value, if it returns 7, let's say it returns 7, let me pick some other color. Yeah. So let's say it returns 7 to 2. It's saying that, yeah, I'm present in the left subtree, and it returns the null flag saying that I'm any of the two nodes, not present in the right subtree. So in this case, 2 received these two values from here. So it got that, I am not the LCA. Okay. So it will return which will be not null right here. So it will simply return to 5 the 7. Okay, saying that, yeah, this is what I found from my left subtree. And similarly, when when it actually 6 is also already processed, that is why it will simply return a null variable to null flag to 5, saying that no, uh, both of the any one of the node is not present in the left subtree. Okay, that is why it will return a null. So in this case also, 5 received a null from its left side, and a not null variable from its right side. Similarly, it will just return the not null flag or not null value to its parent, that is 7. Okay. And similarly, when the right subtree is processed, so again 0 is returning a null, and 4 is returning a not null, saying that it is 4. Okay, and it will return a null. Cool. So in both of this received value, it will just return 4 as the value, because 4 is a not null variable, and it is found out from its right side of 1. So see right here, as we already discussed this particular case in this particular example, while this particular element was 4. So in this case, this particular node is received both not null variable from its side. Okay. In this case, it will say that, yes, I am the lowest common ancestor of both this my descendant, isn't it? And it will simply return 3 as the answer. Okay, I hope the solution is clear. So let me quickly erase this thing. Yeah. So I hope this is pretty clear to you. So now just quickly jump into the code, and it is super easy solution, super easy concept. If you will just go through the solution once, carefully, this is nothing. Okay. So now just handle the best case. Let's say while traversing to find out where the 7 residing, and I hit 6, and this is the left node, and in 6 I find again I'm just trying to go down to find out, but there is nothing. In this case, I should return a null, saying that, see, you just raise out of the boundary of this particular tree. Okay. So if there is nothing, I should return a null. Okay. And if I find out that, let's say, I find out this particular node right here, I do not need to, populate or, propagate this particular uh, tree, or, if I just find out this particular value, I do not need to go down to find out, to explore more and more. Okay. So this is the node that I was looking for, just return it to its parent. Cool. If I find out that the value of root node is similar to any one of the given nodes, like either P or Q. Okay, then I will simply return the root. Okay, cool. Here I will this was the base condition that need to be checked very first. Then I will simply traverse the left part, okay, and the right part, right separate basically. And here I will just call this particular function to just populate or propagate the left subtree for the same to check whether it is present or not, and similarly in the right subtree. Okay, so let's check the left side and similar thing for the right. Okay, so after actually propagating all these things, all this side, what I got two different values for this particular root node. Okay, let's say this is the, I'm sorry, let's say this is the tree. I mean two wait, I'm just, let me just pick a pen. Okay, let's say this is the tree and I am dealing with these two values 7 and 4. Okay, so whenever I just I just propagated the left subtree and right subtree for this particular root node. After just populating all these things, I got the left and right subtree value. Okay, like this, like in the code I have written, I just called the left subtree recursively, similar case for the right subtree, and I just found out something. Okay, from this two node. So here I need to check the condition that I was talking about. If let's say both of the from both of the side I got a null value. Okay, let's say this particular example, let's say 6. Okay, in 6 what is happening, because in from both of the side I get nothing, so this thing will return it a null. Okay, saying that, oh my god, actually none of these two item actually present in ours, inside you, or below you, we can say. So it will simply return a null to 5, and so on and so forth will happen. We'll see. Okay, just one sec. Just erase these things. Okay, cool. So here, if left subtree and right subtree is null, then obviously it will simply return a null, okay, to its parent. Otherwise, if I found both left subtree and right subtree, as not null variable, like this, as I have told you, like this particular let's say I'm taking 7 and 4 into consideration. So these two value will return 2 in not null parameter, not null value, like it will return 7 and it will return 4, you know then it will find that, yeah, I am the lowest common ancestor, and it will just return its value like 2, okay, to its parent. So in this case it will simply just return the root. Cool. And otherwise, if one of the value received from the any one of the two side is null, and other one is received as not null, in that case we will, as I have already told you, that we need to just return the not null value to its parent. So we need to return, if let's say left subtree is the value from received from the left subtree is null, then I need to return the value received from the right subtree. Otherwise, if that is not the case, then I need to return the value received from the left subtree. Okay. So I hope you got the thing. So now let's check it whether it is working or not. Okay. Yeah, it is saying it is accepted. Now just hit it to see whether it is working or not. See, in lead code we are not you know given the constraint of things, so that, okay, anyway, yeah, so it worked, and it worked few seconds ago. Anyway, so yeah, this is the solution, and I hope you enjoyed throughout the session. And please, subscribe the channel, hit the like button, and keep practicing. And please comment in the LinkedIn as well, uh, to what you actually want to learn in next time. Okay, so thanks.